Good morning, students. In today's class, we will learn about the training and test dataset in any of the machine learning model. So first we will see that how we will split the dataset into two parts. That first is the training set and second is the test set. So suppose if we have given training to a machine learning model by a dataset, and if we test it by a completely different dataset, then what will it do? It will create some of the difficulties because the training dataset is totally different than the test dataset. So the machine learning model will not be able to understand what is the correlation between the two datasets. So for example, if we train a model very well and its training accuracy is also very high. So but if we provide a new dataset which uh, is not completely correlated to our training set, then it will decrease the performance. So what we will do, we always try to make a machine learning model which performs well with the training set and also as well as with the test data set. So how we can do that? Suppose we have a data set. So from this data set, we divide some of the part for training set and the rest for the test set. So what we will do, we have a full data set. From this full data set, suppose 80% we keep it for the training set and remaining 20% for the testing set from the same data set. So how we can do after that training set, we will further divide it between the training set and the validation set and the testing data set. So what we can define them as training set. It is a subset of data set to train the model. And for this, we already know the output. Test set, a subset of dataset to test the machine learning model, and by using the test set, the model predicts the output. So we have four sets, means two pairs, matrix, features, and dependent variable of training set, and matrix, features, and dependent variable of the test set. So the two pairs will be matrix, features, and dependent variable of training set, matrix, features, and dependent variable of the test set. So xtrain and ytrain will be the input. After that, fit method, and xtest will be the predictions and ytest. So let us see how we can implement the training and testing in any of our dataset. So we will be using the same dataset which we will have used in our previous video. That is this one. We have a country. After that, values. As you can see that this was our dataset in the previous. Country, age, and salary and purchased. So from this country, age, and salary, we have taken as X means independent variable and the purchased means Y dependent variable. So after that, we have applied one-hot encoder so that we can convert these countries into the numeric terms. And also we have filled these NaN values with the means. So after that, our data set will look like this. This is our data set. We have converted all the countries and categorical data into the numeric data and filled the NaN values. So this is the X part and this is the Y part. Means this is whole data X is independent variables and in Y we have dependent variables. So from this data set, so for this, we will use the sklearn library. From sklearn.model selection, we have imported the train, test, and split function. And the variables we have taken xtrain, xtest, ytrain, ytest is assigning to We have called this function train test split, and in this the arguments given as x. So this x will take x train and x test, and after that y, which will take y train and y test. Test size is equals to 0.2, means 20% will be the test size and 80% will be the training. Random state equals to 1. It means that every time we run the code with random state values 1, it will produce the same splitting data set, means it will not change the splitting of the data set. So after that, when we apply this function and run on our data set and print the x train only, you can see the 80% of the data from the x, means independent variable data, has come into the x train variable, and remaining 20% has come into the x test variable. Similarly with the y train, 80% from y has come into the y train variable and 20% has come into the y test variable. So in this way, you can split the data. In this we have example, we have taken a 0.2 test size, means 80-20. You can also take 0.3, it means 70-30%. In this way, we can split the data set into the training and testing part. Thank you.